So in this lesson, you're going to be able to identify and apply properties of equality, and you're going to be introduced to writing a two-column algebraic proof. Okay, so we are going to look at some algebraic properties of equality. Now, we have the addition, subtraction, multiplication, division. Those are all very familiar to you. You've seen them maybe a little differently than this. So maybe an example of the addition property. Let's say I have, and there we have an example we'll go through. So I'm going to kind of write off to the side here. Let's say I have 5 is equal to 5, and I want to use the addition property of equality. Well, what it means is if you do something to one side with addition, you have to do it to the other side with addition. In this case of an equation. So if I took 5 plus 2, well, that would be 7. Well, again, if I do something with addition to the left-hand side, you also have to do it to the right-hand side. So it's 5 plus 2, you still get 7 out of the deal. So all addition property, again, of equality says, if you do something with addition to one side, you have to do it to the other side. Okay, now we're going to use, I'm going to erase this now. When we talk about this in our notes, we're going to be using variables instead of integers here. So for instance, if I have A is equal to B, well then A plus C equals B plus C. So if whatever they were to start with, is equal, then when I add C to the left-hand side, you're also going to add it to the right-hand side. Now, this is the same thing for subtraction, multiplication, or division. So again, I'm not going to go through the example kind of like I did for subtraction, but you get the idea. If I have like 10 equals 10 and I subtract 3 from each side, so 7 equals 7. Okay, well, if I have A is equal to B, whatever they represent there, if I subtract C from the left-hand side, then I have to subtract C from the right-hand side as well. That's what subtraction property of equality says. Multiplication, if I'm going to multiply A by something, then also I'll have to multiply B as well in order for this to stay equal. Again, the idea is if you do it to one side, you have to do it to the other. And I know you've heard that before in your algebra classes. The only stipulation with division now is that you cannot divide by 0. You're not allowed to divide by 0. It makes it undefined. So anyway, so now let's get to maybe something that you've seen this before, but you're kind of like, oh. So reflexive property, all it says is this, is for any real number A, it's equal to itself. So literally A equals A. Symmetric property, it says, hey, if I have A equals B, then I can say B equals A. And again, the concept of symmetric property, you've used it a ton. If you solved and you got 5 is equal to A, but you want to go ahead and flip this so that it's A equals 5, we use the symmetric property all the time in algebra. Because again, we like to see the variable on the left. Okay, transitive property. This is where we're starting to get to some things that would be a little more new to you. Okay, so transitive property says if A equals B and B equals C, well, what can you conclude? Well, that A equals C. Okay, and then substitution property. You're just replacing something. So if I have A is equal to B, then A can be substituted for B in an equation or an expression. All right, so again, when I think of substitution, because I'm a soccer coach, I think of soccer. When I take a player off the field and put a new player in, it's literally replacing one piece of something, so like the team. So that's substitution. It'd be like going in, replacing one of your tires. You're getting a new tire, you're replacing the tire, or something like that. Okay. Let's look at some examples. For each statement below, what property was used to make the conclusion? So you're going to use the information from the previous slide, read these if-then conditional statements, and determine what property had to be used to make the conclusion. Because remember, we have a hypothesis, and we have a conclusion here. Okay, a hypothesis and a conclusion. So how do we, and these are line segments. So if the segment ST is equal to the segment TU, then I know that TU is equal to ST. Now, looking at this equation, hopefully you notice that all they did is flip it about the equal sign, which we know that if you're flipping it about the equal sign, that's the symmetric property of equality, the symmetric property of equality. I abbreviated because that's what I do. The second one, if TU equals RS and RS equals MV, then you conclude that TU equals MV. Now again, it's noticing that there is kind of a flow to this, okay? You have TU equals RS, so I have TU is equal to RS, and then I have RS is equal to MV right here. So what can you conclude? That TU is equal to MV. Now I'm kind of marking this a little weird. I should use a different color, but that's okay. So I hope you're noticing a pattern here. If TU equals RS and RS equals MV, then your conclusion, TU right here is equal to MV right here. So it's almost like you can get rid of the RS here and here and just write TU is equal to MV. So what property did that for us? Well, that's the transitive property. Of equality. Now, here's the thing. People love the transitive property. They use it in, and I'm sorry if you don't like sports, but I'm going to use an example in sports. So let's say people use it all the time to try to compare teams. So say, well, my team beat your team, okay, and you guys beat John's team. So therefore, my team should be able to beat John's team. You know, that kind of thing. So people try to use the transitive property all the time, and it doesn't work that way, by the way. But they try to use it all the time in places where it doesn't belong. All right, if ST plus TU equals SU, and TU is 4, so we have TU being 4, then ST plus 4 equals SU. So hopefully you're recognizing that this 4 was plugged in place of the TU. Now remember my example was, again, because I'm a soccer coach, was, hey, if I substitute someone in, I'm replacing like one person or a couple people in a lineup. Well, what happened here is the TU was replaced with the 4. So we use the substitution property. Ooh. Now, we got to be careful with abbreviating that we go, SUBS for substitution. Just to be mindful that we don't confuse it with some of the other properties. So don't get super lazy and try to abbreviate any more than that. So SUBS is good for abbreviation for this. Again, we have 6 more here to look at. I'm going to go a little faster, just kind of speed this up a little bit. Okay, so if ST equals 5, then 2 plus ST equals 7. Well, again, you have a hypothesis, and I haven't been labeled this in the other ones. Maybe I should have, just to kind of reinforce that. Again, there I am, taking longer. So if ST equals 5, then 2 plus ST equals 7. Well, what did we do here? Well, we added on here, we added 2 plus 2 to the left-hand side. Well, wait a second. This 7 right here, this 7 is not what we had over here. Well, what did we do to the 5 to get 7? We added 2. So on here, hopefully, what you're seeing is they went ahead and they took, because ST and 2 aren't like terms, they can't combine, but 5 plus 2 is 7. So what we used here is we went ahead and we used the addition property. So you'd write addition property. We use the addition property by adding 2 to both sides. All right, the top right, if you have A, then A equals A. This one looks really weird. So again, you have a hypothesis, A, conclusion, A equals A. Anyway, so again, if I have something and I set it equal to itself, that's the reflexive property. I didn't really mention this when I first talked about it on 2 slides ago, but when you think of reflexive property, think reflection, think mirror, think yourself. If you go in the bathroom and look in the mirror, you see, well, hopefully yourself. It'd be weird if you didn't. But reflection, reflexive property, think reflection. Okay, please don't call it the reflection property. It's reflexive property. Okay. Going to the next one on the left. If xt equals 5, then xt minus 1 equals 4. Again, hopefully you're starting to kind of notice the tricks of this. Wait, how did I get from 5 to 4? Oh, I must have taken 1 away. Well, that's what's written here, minus 1. So what property says if you subtract something from one side, you can subtract it from the other side? Well, that's the subtraction property. Notice how I went SUBT. The reason why I'm going to the T here is because I don't want to confuse that with the substitution property. That's where the previous slide we went SUBS. So subtraction property. Next one. If LM equals 12, then 3 times whatever LM is equals 36. So again, hopefully you're noticing here, wait, how did 12 become 36? Oh, I multiplied it by 3. So this is the multiplication property. Bottom left, if 3x equals 9, then x equals 3. Again, for this one, how did you turn 9 into 3? Well, again, hopefully you're recognizing, oh, I divided by 3. You could try to say, oh, I subtracted 6. But again, I went from 3x right here to x. So I definitely didn't subtract 6 from 3x and get x. So we use the division property. We use the division property because we're dividing both sides by 3. Last one. I have 4x plus 4 equals 12. Then 4x equals 8. So hopefully you're recognizing that we're just subtracting 4. So this is subtraction property here on both sides of that. So looking here, we're saying, okay, using the property listed, complete the statements below. So symmetric property of equality. So again, think symmetric. Remember, symmetric is a lot like the converse. It flips the order. Symmetric flips the order. So if AB equals YU, then what can you conclude? Well, hopefully you get YU is equal to AB. Again, symmetric is you're flipping this. Addition property. If AB equals 8, then AB plus 6 equals, so again, it's recognizing how for number 1, we rewrote this entire thing. Here, we're just rewriting the right-hand side. So it's important you're recognizing what they're doing. They're adding 6, right? So then you just do 8 plus 6, okay? So it would be 14 here, okay? So AB plus 6 equals 14 because that's what 8 plus 6 is, it's 14. Reflexive property, remember, again, reflexive, reflection. So looking in a mirror, so it would be the measure of angle ROP. You just rewrite it. Substitution, again, we're looking to replace something like substituting a part on a car or substituting a substitute teacher. A teacher comes in here instead of me, okay? So if LM equals 7, then EF plus LM equals NP. Again, recognizing it wants you to substitute. So you're going to take this 7 and put it in place of what LM is. So you're going to write EF plus 7 equals NP. Transitive property of equality. Again, remember this one's going to have to have a flow to it. So and remember transitive property, initially we said if A equals B, and then we know that B equals C, then what can you conclude? You can conclude that A is equal to C. So it has to have a flow to it like that. Okay, maybe those. Get rid of that there. Okay, so again, it has to have kind of a flow to it on this. So if AB equals BC and BC equals ZY, so then AB equals ZY. Hopefully, again, you're noticing, hey, these are the same here and here. That's what's going on with transitive property, okay? Those are the same. So it's almost like you're just taking whatever it started with here and setting it equal to what it's ending with there. Multiplication property of equality. Oh, by the way, transitive property, tied this into last lesson. should have thought of this soon. It's like a lot like law of syllogism, remember? So if with law of syllogism, I could say if Mr. Borkland's soccer team wins, then he will be super happy. And then you could say if Mr. Borkland is super happy, then he will take his family out for ice cream. And so what you can do is take those two statements using law of syllogism, or technically transitive property. Okay, you could say if Mr. Borkland's soccer team wins, then he will take his family out for ice cream. Okay, so it's taking those two if-then statements and writing a new one. I know these aren't if-then statements, but it's kind of doing that. Anyway, number 6, multiplication property of equality. So I have the measure of angle ABC equals 20. Oh, I'm multiplying it by 2. Again, recognizing what's missing, just the right-hand side of the equal sign, 40. Division property, 5 times AB equals 45. Oh, it's just AB. And I'm dividing here. So it's got to be 9 because I'm dividing by 5. Subtraction, again, so taken away. Okay, the measure of angle ZYA equals 35 degrees. And then you have the measure of angle ZYA minus 16. So you're going to just come over here and you're going to take 35 degrees and you're going to minus 16 from it. Notice my degree symbol. Okay, so where are we going with all of this? This is a basic version of a 2-column algebraic proof. So you've solved algebraic equations. You've been doing it. You were doing it in middle school. You did it in your algebra class. Okay, so you've been doing it for a while. So where we're going here is we're beginning to get introduced to what a proof looks like. Okay, so I have up here, I have the equation 10 minus 2x equals 3 times x minus 2 inside parentheses plus 4. So you need to solve it step by step and give the reason for each step. So to do this, you have to think like the person who's doing this. Now, whenever you're writing a proof, you will always, always, always start off with the given. So this is something that you're going to get very used to. Okay. So when we start our proof, well, I would say, when I say always, let's say 90% of the time, you will start with the given. So we're going to start off writing the given. Then we're going to look and say, okay, now the proof is actually already kind of done for you. All the algebra is there. So we have to think like the person who did this. So we need to look, okay, how do I get from line 1 to line 2? So here's line 2 right here. So how do I get from line 1 to line 2? Well, I noticed that I still have the 10 and minus the 2x. All of a sudden I got a 3x minus 6. Well, what do we do to get from there to there? Well, I distributed the 3 times x and the 3 times 2. Okay, so we use the distributive property, which I know I didn't go through and explain that on the previous slides, but you should know the distributive property. Okay, and if you forgot the distributive property, welcome to refreshing your memory. Okay, so now again, looking, left-hand side did not change. It stayed the same all the way through here. The right-hand side though, I went from a negative 6 plus 4 to a negative 2. So I combine like terms. That's what we did. When we do this, it's called simplify. We simplified it. Combining like terms, simplify. If you wrote combine like terms for the reason there, so we have our statements on the left and our reasons on the right, I would take combine like terms also. Okay, again, it's thinking like the person who wrote this things. Okay, so all of a sudden, oh, what's gone? Well, the minus 2 is gone. So I moved it over. How did I get it over there? Well, I must have done the opposite operation, right? Which means I would have added 2 to both sides. So what property did I use to get from line 3 to line 4? Well, I used the addition property. So property of equality, but you can just leave addition property there. what some students may be tempted to say here is subtraction or something, but again, it's what did we really do? Well, we added 2 to both sides, so it's addition property. Okay, so now again, noticing what's here, we have a minus 2x, we have a 3x here. I'm going to erase this. Okay, we have a minus 2x and a 3x, and all of a sudden we now have a 5x here. Well, how did I get from that line, line 4, to line 5 on here? Well, I moved this 2x over. Again, we used the addition property of equality. We added 2x to both sides. That's a really terrible 2x. Okay? So again, it's the addition property. Use the addition property of equality. Lastly, on here, we have a 12 equals 5x in line 5. In line 6, it becomes 12 over 5 equals x. Hopefully you're recognizing a division came in here, so we divided 5 on both sides. So we use the division property of equality. And congratulations, that's your first proof.